Hello, welcome to this video 6-5, and today we are going to talk about the fundamental theorem of calculus. And our intention is to calculate definite integrals using the fundamental theorem of calculus. So here we have a graph f prime of x shown in the figure to the left, and we want to talk about what is the expression, the integral from 0 to 2 of f prime of x dx represent. Well, up until now, we have talked about this representing the area between the x-axis and f prime of x, specifically from x equals 0 to x equals 2. That's the area bounded by that region. And we have examined the area under the curve in various ways. We've looked at contextual examples to see what it represents in specific situations, and we've also discussed various ways to find or approximate the area. However, we want to find the exact areas under the curve, even if it's not made up of geometric shapes. So in order to do this, here is where we need to go ahead and we need to utilize calculus. And we're going to utilize a theorem called the fundamental theorem of calculus. And I'm not going to go into, in this video, how to prove or how the fundamental theorem of calculus is derived. I can go ahead and post a video by Khan Academy. He does a great job of explaining how this is derived and proved to my website, and you can view that there if you want. But here is what the fundamental theorem of calculus in order to evaluate definite integrals says. If the function f prime of x is continuous on the closed interval a to b, and that's very, very important, then the integral from a to b of f prime of x dx is equal to, well, it's very important to know that an integral is an antiderivative. So if I'm integrating f prime of x, that is f of x. It's just the function f of x, right? And I could go back to f prime just by taking the derivative of f of x. Now the bounds, we say we're evaluating from a to b. Okay? And how we calculate this is we simply subtract the function evaluated at b, the upper value, minus f of a, or the lower value or lower limit. Okay? And that's it. It is the antiderivative evaluated from the upper limit minus the function evaluated at the lower limit. Now let's go ahead and look at another representation of this, and let's just consider, what if I have a function f of x that's continuous on the closed interval a to b? Then the integral from a to b of f of x dx, again, now I need the antiderivative, and this is just a little bit of notation, is capital f of x evaluated from a to b, which is equal to capital F of b. You plug in the upper limit minus f of a. You plug in the lower limit. And that is the fundamental theorem of calculus. Very, very straightforward. So let's go ahead and do some quick examples to see if we can get this right. Example 1, a. The integral from 1 to 5 of g prime of x dx, this is equal to, well, the antiderivative of g prime is g of x, and I'm going to evaluate from 1 to 5. So I plug in 5, so g of 5 minus g of 1. And that's it. That's it. I don't know what g of x is, and I don't really care. Here we just want to go ahead and see if you can set up the fundamental theorem of calculus application. All right, b. Here we have the integral from 5 to negative 2 of h double prime of x dx. Now, before I go ahead and integrate this, the first thing I'm going to do is correct my limits of integration. I want the integral from negative 2 to 5 of h double prime of x dx. And if I go ahead and integrate this, I have negative. Now the antiderivative of h double prime is just h prime of x. And I'm going to go ahead and evaluate from negative 2 to 5. Okay, so if I plug this in, this is negative. I'm just going to keep that constant on the outside, and I'm going to evaluate h prime at 5 minus h prime of negative 2. Okay, and that is the fundamental theorem of calculus. So let's go ahead and look at some applications. Here I have a graph of g of x consisting of the 3 line segments given above. Use the graph of g of x to find the following. All right, A, the integral from negative 1 to 3 of g prime of x dx. Okay, so I am going to take an antiderivative. So this is g of x, and I'm going to evaluate from negative 1 to 3. Okay, so this is g of 3 minus g of 1. And here's where you need to be conceptually aware of what's going on. Notice they give us the graph of g of x. So what I'm finding is I'm finding function values. So g of 3, that's right here, that is 1, minus g of 1, which is 1, and we get 0. Okay, so the answer is 0. Let's look at B. The integral from 6 to 1 of g of x dx. Well, I'm going to go ahead and I'm going to fix my limit of integration. This is the integral from 1 to 6 of g of x dx. And if we do this correctly, we get negative capital G of x evaluated from 1 to 6. Now, I could go ahead and I could plug in the 6, capital G of 6 minus G of 1, but this is not going to really help me here in this situation because I don't know any information about the function capital G. But what I do have is I have regular lowercase g of x given to me. Well, if I want this right here, the integral from 6 to 1 of g of x dx, can't I just find the area under the curve? Why, yes, I can. So I can go ahead and calculate this. Here we have 1, 2, 3, 4. What we got? 1, 2, 3, 4, 5. Got another one here, 6. And that area is going to make up 7. Okay, so I'm just counting those geometric regions, and that was a fairly straightforward. So I do have that negative on the outside, so it is negative 7. All right, let's go ahead and look at C. Okay, the integral from 5 to 6 of g double prime of x plus 4 dx. Okay, well, integrating my first region, we have g, that's the antiderivative of g double prime is g prime of x, okay, evaluated from 5 to 6, plus I have 4, that's my height, the function, the height is 4, times the difference between 6 and 5, that's just 1. Okay, so now I have g prime of 6 minus g prime of 5. Remember, it is always top limit minus bottom limit, okay, plus 4. And now I have to go ahead and I have to find what's g prime of 6, what is g prime of 5. Now notice this is g of x. So if I want g prime at 6, that is right here, that's the slope at this location. The derivative of g prime, that's the slope at 6. And it looks like we have a slope there of 1. And also for 5, slope of 1. So answer is just going to be 4. 1 minus 1 plus 4 gives us 4. All right. Let's go ahead and move on to some tabular examples. So another method that you could see the fundamental theorem of calculus arranged on the AP exam. They say the function f of x and its derivatives are continuous for all real numbers. Selected values of f prime, f double prime are given in the table above. Use the table to answer the following. So let's just go ahead. Same idea. Nothing revolutionary here. We've already kind of looked at some of these examples. The integral from 1 to 6 of f prime of x dx. Okay, so this is f of 6 minus f of 1. Okay, and I'm going to go to my table. I'm going to find this. So what is f at 6 negative 3. So I have negative 3 minus, and be careful, you always need subtraction in there, so if your second term is negative, just be careful to put parentheses around there so you don't lose a negative, minus 2, and we have negative 5. That's a 5 as our answer. B, the integral from 13 to 3 of 2 f prime of x dx. Well, I'm going to go ahead and fix my limits and also pull out that 2 as a constant factor. And I have f prime of x dx, okay? So this is equal to negative 2. I'm just going to let that sit on the outside. And I have the integral of f prime of x. So that is f of x evaluated from 3 to 13. So I plug in 13 first, then I subtract the 3, top minus bottom, okay? And I just have to find these values. So negative 2 times f of 13, that's 10. 10 minus f of 3, which is 7. That gives us 3. So negative 2 times 3 gives us negative 6. There's your answer. All right, we're cooking. C, here we go. All right, I'm going to go ahead. I'm going to have an opportunity for a practice problem here. Please go ahead, pause this video, and try this example. Okay, hopefully you were able to pause the video and try this one. Here, I'm going to go ahead and integrate f of x. That's going to be capital F of x, evaluated from 7 to 6. Okay, minus 2, evaluated from 7 to 6. Your width here is 7 minus 6. That's just going to be 1. And f of 7, capital F of 7, was 5. Minus capital F of 6 was negative 2. There's that parentheses that I was talking about. Minus 2. This gives us 5 plus 2 minus 2. Answer is 5. So hopefully you got that value. All right, about 3 more examples here. Let's go ahead and look at D. The integral from 7 to 1 of f double prime of x. Here, I mean, you start to get the feel for these problems. I'm going to correct my limits. I have f double prime of x dx. So when I integrate, that's going to be f prime of x. And I'm going to subtract from f prime of 7 minus f prime of 1. And I'm going to use my table. So let's go ahead and see what tabular values this gives us. So f prime of 7 looks like negative 3, and minus f prime of 1 is 8. Negative 3 minus 8. Okay, so we have negative 11. With a negative attached gives us a positive 11. E. Here we go. The integral from 3 to 13 of f prime of x plus 3 dx. Okay, so this is going to be equal to f of 13 minus f of 3 plus 3 times 13 minus 3. That would be times 10. So we get f of 13, looking at our table of values, is 10 minus f of 3, which is 7. So 10 minus 7 plus 3 times 10 is 30. We get 33. All right, and F. The last example here. Please go ahead, pause the video, try this example, see if you can get this solution correct. All right, so F, we have the integral from 6 to 3 of negative 2 f of x dx. We're going to factor out the negative 2 and then also switch our limits. So 2 negatives make a positive. So the integral from 3 to 6 of f of x dx. And I have a 2 on the outside. And it's capital F of 6 minus capital F of 3 times 2. And this equals, we're going to check our table of values. Capital F of 6 gives us negative 2. Capital F of 3 gives us 6. So negative 2 minus 6 times a positive 2. And we get 2 times negative 8, which gives us negative 16. All right, that's going to do it for this video. In this video, we went ahead and talked about how we evaluate definite integrals using the fundamental theorem of calculus. Hopefully you liked the video. Give me a thumbs up and subscribe, and I'll catch you guys in the next video. See ya.